The CLO for this lesson is students will be able to identify in writing quadratics using their forms in the following language. If-then statements, quadratic forms, standard form, factored form, vertex form. So in your own words, what do you think we might be talking about in this lesson? So like always, I'm going to start explaining the vocabulary words down here. So to start these notes, the first word is a quadratic. So zoom in. A quadratic is an equation where the biggest exponent is 2. What do I mean by that? So in math, we have tons of types of equations. And you'll learn all about these equations. There's tons of them. The first one that they ever taught you about in your first year of math is something called a linear equation. And linear equations make straight lines when you graph them. Now, if we talk about exponents in this linear equation, 1 has an exponent of 1. Like this, it's an invisible 1 because there's one of them. See how it doesn't change the graph at all. This 3x also has an invisible exponent of 1 because there's no exponent there. So linears have x's in them, but these x's have the exponent of 1, or you could almost say like no exponent. It just is there by itself. And so those are linears. We also learned about equations called exponentials in the first year of math, where actually the exponent itself isn't a number, but rather it's an x. And these kind of make graphs that that's this blue one, kind of curves like that. Those are called exponentials. And so those were the first 2 types of equations that you've learned about in high school math. Except everything in the world is created by an equation. Everything everywhere is created by an equation. For example, see how this one kind of makes that back and forth U shape? So the U shape is a type of graph too. And the U shape is called a parabola. Parabola is this kind of like a U shape. Other things in real life that make that shape, there's tons of them. See, there's arcs. Oh, because you can flip them upside down and they make like ends. They're still parabolas. So arcs are roller coasters. In structures like water fountains, when water comes out of a water fountain, it makes the parabola shape. So all of these things, rainbows, bananas, all of these things, you have to be able to create them from like a machine, you have to be able to put an equation to it. So everything you see in real life has an equation somewhere that matches it. And so while like let's look at the Golden State Bridge. If you look at the flat part where the cars are, since it's a flat line, that would be represented by something called a linear, because the linears make flat lines. But then if you look at the shape of the wires holding it, those make the parabola shape. And so to create this bridge, the architect, the person who made it, had to know the equation of this linear, and they had to know the equation of this quadratic to make it work out and to actually create this whole thing. So that's what quadratics are in terms of real life. But in equations, what they look like is quadratics have equations where the exponent on x, the biggest one is a 2, is a squared. See how it makes that U shape, that parabola shape? Now, if it's negative, it flips over like that, and that's how you get the N shape, because it turns upside down. It doesn't matter if I add like an x term. It might change the graph a little, like where it's at, but it still is this U shape, this quadratic shape. If I add just like a number, still that U shape. The problem is let's say, so another x term, still a U shape, but let's say I put an exponent on it like a 3. It's not a U shape anymore. So if the exponent is bigger than 2, it's not a quadratic. If it's less than 2, if there's no squared there and it's just an x, it's not a quadratic either. It's just a linear, it becomes a straight line. So the rule is where the biggest exponent is a 2. It can't be a 1, it can't be a 3, it has to have an x squared in it. Has to have an x squared. And no bigger exponents. Because smaller exponents are fine, like just x's are fine, or just numbers, but no bigger exponent than a 2 to be a quadratic. So this is what we're going to talk about. This is what the next 2 units are about. All about quadratics. And the whole point of this unit, like if we went into Schoology and we looked at the title, the name of the unit we're on, here, I'm going to just show you. This whole quarter, this is solving for x with quadratics. So the whole thing's going to be about quadratics. And the next one is graphing quadratics. So this whole quarter, we're learning all about the quadratic function. And remember, quadratics, their shape is called a parabola, which kind of makes the U or N shape. Oh, not that type of N. This type of N, like a curvy one. All right. So this is, when I shape of the graph is called a parabola. All right. So the whole point of this is lesson specifically is we want to talk about the 3 forms of a quadratic. So when I say form, all I mean is the structure. Structure also means setup of the equation. So in math, you can write things in a lot of ways, and they mean the same thing. For example, I could write 5 plus 5 plus 5, and that means 15. Or I could write 3 plus 3 plus 3 plus 3 plus 3, and that's also 15. So these are different forms of the same answer. But also, both of these just mean that we're taking 3 times 5 or 5 times 3. And these, so this is the adding way of writing it, the adding form, and this would be the multiplying form. So all of it's saying the same thing, it's just written in different forms. So with quadratics, we have 3 main forms that we use all the time. One of them is called standard form. The other one's called factored form, and the next one's called vertex form. We have to learn these really well. We're going to use the forms a lot. So let's talk about all of the different forms and what they look like. So standard form usually looks like this. They usually start with y equals. They could also start with something called f of x. This just means y. It's just a big word to mean it's a function. So it's the same thing as y equals. And then this is the typical, most standard form of a quadratic. A is the first number, and a goes with your x squareds. And then you have b with your x's, and then c is the number all alone. So some examples of this might be so in this case, the a, the number in front of the x squared, is just a 1 because there's nothing there. The b comes next because they go with the x's, and my b is -3. And then the c is the number all alone, and that's the +1 right now at the end. So this is standard form, and it's the most standard way to write a quadratic. But I could change it, and I could take it, and I could write it in something called factored form. And here's what factored form generally looks like. This one's factored form, and the reason why is because after you factor this, it looks like this. But this is still a quadratic because once we multiply it back out, the x times this x will become an x squared. Um, and so, yeah, this is factored form. An example of this could look like this, for example. In this case, the d would be a -3 and the e would be a +4. X always stays there because x is our input. And until I'm telling you to put something in there, it's going to just stay as an x. Same thing as the y. But what changes in these forms are the d and the e. Just like here, what changes is the a, b, and c. But x's and y's always stay x and y's in equations until they tell you to plug something in. So this might be a factored form one. It's also important to know I could have things in front of here, for example, like a 5. Or I could have something in front of the x's too. But you don't have to. And then finally, vertex form ends up looking like this. Where there ends up being something in a parentheses being squared with x, and then some number after it at the end. And the reason why it's called vertex form, you will learn a little bit later on, but for now, this is what vertex form looks like. I didn't mean to write a 2, I meant to write a k. The letter there is a k. An example might be y equals x minus 1 squared minus 3, where in this case h is -1 and k is -3. But again, remember, the squareds don't change, the x's and y's don't change. It's the other letters that are changing for the different forms, because this could have also been +7. And now in this case, h would have been +7 or +7. All right, so those are the 3 different forms of quadratics, and we're going to be working with them for the next 2 units. One of the things, we're gonna have to do a lot with them, but one of the things we're gonna have to do is be able to go between any of the forms. So let's say I'm given a situation, and someone said, in my situation, let's say I'm building a skate ramp, and they said, this is the equation for my skate ramp. So I graph it, and it looks like this. I'm like, all right, this is the graph of the situation. But right now, this equation is in what form? It's in factored form because it has the 2 parentheses. I could take this form and I can do some math and I can turn it into standard form, and this equation is the exact same as this one. To prove it, if I were to graph it, look, graph, the blue one went right on top of the red one. If it was different, like if this wasn't a 15 but a 14, then it would look different and you could tell them apart, like here's the red, but there's the blue. But since they're the exact same equation, they overlap each other. And if I did some math and I put it into this form, and what form is this one? Vertex form. If I put it into vertex form and I graphed it, green, look, it goes right on top of the other 2. Because all 3 of them are the same equation. They're just all written in different forms, which is why it's important to be able to go back and forth between all 3 of these. Because even though they're written differently, they secretly are just the same thing. So like if I start in standard form and I want to go to factored form, I already told you that we end up doing that with factoring. If I started in factored form and then I wanted to go to factored form, though, that is a different process. And you also know it, but it's just called distributing. You also know going from vertex form to standard form, and I'm going to show you how you already know that, but all you really do is you distribute. It's just distributing again. A new one we're going to learn in this unit is if you started in standard form and had to go to vertex form, there's a process called completing the square. So then if I wanted to go from vertex to factored form, there is no process. You would just have to follow the blues. You would first have to go from vertex to standard by distributing, then standard to factored by factoring. And that's the only way to get from here to here. Same thing if I wanted to go from factored form to vertex. There's no process. I would just have to go around. I have to start with distributing into standard and then go from standard to completing the squared over to vertex form. But you're still expected to be able to go between all of these eventually. And then, yeah. And so for today's lesson, your goal, besides understanding like the setup of what we're going to be working on, is to be able to take any quadratic equation and tell me what form it's in. But sometimes it looks really weird. Like, okay, for example, this guy right here. Let's see. Do we think it's factored, standard, or vertex? Vertex has a parentheses being squared. Factored has two parentheses. Standard has no parentheses. So let's write that. Factored, vertex has one parentheses being squared. Factored has two parentheses. Standard has no parentheses. So that's going to be the easiest way to tell them apart. So here, I'm going to grab this and bring it down to our examples so we can look at them at the same time. So looking at this one right here, does it have any parentheses? No, so it should be in standard form. But it's not. It doesn't look quite the same. We need to make it look the same as this guy here. So it should say y equals. But right now, it doesn't. So how am I going to change this? What I'm going to do is I'm going to treat this like I'm solving for x almost, but all I'm going to really do is take this guy and move it over here. So to remember to move it over the wall, how do you move terms over the equal sign? You have to add or subtract them away. So because it's a positive 3, I have to minus that 3x's over to this side. Well, now, when I do 3x minus 3x, they eliminate and I get 0. So I can't put y equals. I would have to put 0 equals, but that's okay. Equaling 0 is as good as equaling y. If you can't have y equals, then your goal is to have 0 equals. So now I have 0 equals. Oh, and I think it's important, just in case you're confused, it doesn't matter if the 0 equals goes first, or if the y equals goes first, or if it goes at the end, like over here. So it would have been the same if I kept equal zeros at the end instead of starting with 0 equals. It doesn't matter. So I'm going to write that equals 0 is the same thing as 0 equals. So in standard form, the first one are the x squared terms. So if I look here, my x squared term is right here. And what number is right in front of the x squared? The answer is -1 because it's negative, but I don't need to write 1. I'm just going to write negative x squared. The important part here is that the negative stays with it if it goes first. Then second should be our x terms. What's my x term on this side? It's the minus 3x, because to move them over, I had to minus them over. There's no x's for them to go with, so I just have to minus the 3x's right after the x squareds. And then finally, the plus c, the number at the end. It was a positive 13 because there's nothing in front of it. So since I'm writing it at the end, I have to write plus 13 for positive 13. And now that all equals 0, and this was in standard form. Now that we've written it properly. This is still standard form, it's just not written properly. Now we've written it properly with either it being y equals or 0 equals. And we have the equal 0 at the end, so we're good. This one, does it have a parentheses? No, it does not, so it is in standard form. We just have to make it look like it's in standard form. And right now it's almost there. It starts with the x squared term. That's great. See, because we want it to start with the ax squared. And right now, what is a in this equation? It's 5. Then next should be the bx, and we do have the x term next. And what is the b right now? It's the 6. But then we should have the c, not the equal sign. So my just number term is over here right now. And to move it over, I have to do what? To get rid of 5, I have to minus 5. I can't minus 5 from you because you're an x squared. I can't minus 5 from you because you're an x. So then my answer just ends up being that I have 5 x squareds, 6 x's, and then I'm minusing 5 for my c, my just number. And now on this side, 5 minus 5 equals 0. And so do I have it in the right order, either equaling y or equaling 0? I do. So now I've done this well and I'm in standard form. So again, all I'm doing is taking this, which was in an improper standard form, and writing it in the proper way. Okay, next example. Does it have any parentheses? It has 1 parentheses. So is it vertex form? Well, here's the thing. Is that parentheses being squared? Because that's really important for vertex form. Right now it's not, which means we have a secret parentheses around this x. And more than that, what can I always add to x? What's the invisible thing you're adding? 0. So now you can see this is in factored form. And actually, it's already in proper factored form. So I'm going to back this up. This was the original question. And to turn it into proper factored form, I had to put a parentheses around at first x. And then I had to add the fact that I'm adding 0, or I'm adding nothing to it. So now it looks exactly like this guy, except instead of y equals, it has equals 0 at the end, which is good, what we want. I would have to say it's in factored form. All right, what form do you think it's in? It's in factored form because it has 2 parentheses. However, right now it equals 12, and that is not okay. So your first step might be, let's minus that 12 over. However, mathematically, you cannot minus 12 from any of this because it's all in parentheses. So you would have to write it like this. But when I write it like this, Factored form doesn't have any number at the end of it. It's not okay to have like plus something there. There's nothing there. And so I can't call this proper factored form. Um, and so actually, this one's a weird one in the sense where you actually have to do some math to change it into standard form. So I'm going to show you. Remember I told you up here you already knew how to do that from factored form to standard? It's this red distributing one. Let me remind you about distributing. When you have a parentheses being multiplied to another parentheses, the rule is that everything in this parenthesis has to multiply to everything in this parenthesis. And there's two methods to do it. There is the arrow method. So I do x times x, and I do x times plus 5. And then I have to do them both with the -1 too. But let's just do those first two. So x times the x becomes x squared. X times 5 is 5x. Then I have to come through and do the -1 times the x and the -1 times the 5. So -1 times x is -1x, and -1 times 5 is -5. But then I have to remember I still have this -12. It's still equaling 0 too. So now when I combine all my like terms together, is there any more x squareds to combine with this one? No. Is there any more x's to combine with these 5x's? There is -1, and 5x minus 1x becomes positive 4x. And then this just number can combine with this just number, and -5 minus 12 is -17. And that's going to all equal 0 still. So now this one had to end up being in proper standard form. There was no way to write it in proper factored form, so I had to distribute it out and get it into proper standard form to make it something that's proper. Okay, for this example, does it have any parentheses? Yes, it has 1, and it is being squared, which means we're in what form? It's almost in vertex form, except it says equals 2, and it should either say equals y or 0, but since there's a number there, it's going to say equals 0. So to make that 2 become a 0, what do? I minus the 2 away to this side. This will cancel and become 0. So then my new equation will be because that's all in a parentheses being squared, I can't minus 2 from any of it. So I just have to write -2 at the end. It's going to equal 0. And now I made my goal of having it equal 0. And now I have it in proper vertex form. So using the vocabulary and if-then statements, explain in your own words what you learned today. For example, if there is no parentheses, then it's most likely in standard form. Or if the equation doesn't equal 0, then you have to make it equal 0. And just tell me everything you learned using the vocabulary and if-then statements.